Okay, so I just thought I would talk you through this example that we had with our group work. Okay, so you're going to start with, remember you're always proving this. So you want to show true for n equals 0. So b sub 0, which is 5, is greater than 4 times 0, check, right? 5 is greater than 0. Okay, so assume true for n equal k. So b sub k is greater than 4k. So now I want to show true for n equal k plus 1. All right, so b sub k plus 1 is greater than 4 times k plus 1. Okay, so this is where I change gears, right? So this is where I go up here, and I'm going to use k plus 1 in this. So that gives me b sub k plus 1 is equal to 4 plus b sub k. So I take this and I say, okay, b sub k plus 1, oh yeah, that's equal to this, 4 plus b sub k. So then I think about what is my inductive step. My inductive step said you can take out b sub k and you can put in greater than 4 to the k. So I take that out and I put in greater than 4k. And then I just carry along this 4 plus, right, for the ride. Oh my goodness, there it is, isn't it? There's 4 times k plus 1. I got there, right? Check. Okay, so the reason this is called strong induction is that you end up having, because you've got this sequence with this recursive defined in terms of the 2 terms before it, in order to prove this, you're going to have to use more than just k. You're going to have to use the k and the k minus 1 terms. So I'll let you look back at this one. I'll do this next one here. But when I put k plus 1 in this, I get this, right? And that's going to be my step. And so now I need to substitute in an s sub k and s sub k minus 1. So that's when it's called strong induction, where you make it true for a range of values. All right, so let's go do this one. So I start off with showing true. Show true for n equal 0, right, and n equal 1. Okay, and remember you're always proving the nth one, right? So g sub 0 is 5 times 3 sub 0, 3 to the 0 plus 7 times 2 to the 0. So this gives me 5 plus 2, so that's 12. Check. Okay, so g sub 1 is going to be 5 times 3 plus 7 times 2. So that's 15 plus 14, that's 29. Check. Okay, so now I'm assuming, so this is where you have to state it very differently. You assume true for I, and where the I goes between 0 and k. And so then you say g sub I is equal to 5 times 3 to the I plus 7 times 2 to the I. Okay, so now when it comes time to go do the proving of it, oh, I'm sorry, let me write that. Let me show true. I forgot the step. Show true for n equal k plus 1. Okay, so g sub k plus 1, 3 times, I'm sorry, not 3, 5, 3 to the k plus 1, plus 7, 2 to the k plus 1. Okay, so now when it comes time to start with this left-hand side, that's where I go to this. And I put in k plus 1, right? So I'm putting in k plus 1 into here. So g sub k plus 1 is equal to 5g sub k minus 6 g sub k minus 1. Good thing I've got this strong induction, so I can use the k and k minus 1 into here. So let me just go here 5 times, and now I'm putting in k, minus 6 times, and now I'm putting in k minus 1. Okay, so I'm going to suggest first we just multiply these numbers in. So I get 25, 3 to the k, plus 35, 2 to the k, minus 30, 3 to the k minus 1, minus 42, 2 to the k minus 1s. Okay, so I want to join these, right? This is 3 to the k, and this is 3 to the k minus 1. So let's put them together, or next to each other. And as I'm so this one's this, right? As I'm rewriting this, I'm going to factor this 30, so I get minus 10, and then 3 times 3 to the k minus, 3 to the k minus 1, because in the next step, I'm going to multiply these to get 3 to the k. Okay, so let's take this, so plus 35, 2 to the k, and as I'm rewriting this, I'm going to rewrite 42 as 21 times 2, 2 to the k minus 1s. So let me go slow. So this is the same as saying 3 to the k, right? So I have 25 3 to the k minus 10 3 to the k's. So this right here is the same as saying 2 to the k, right? So I have 35 2 to the k's minus 21 2 to the k's. So now I can add these 3 to the k's together. So 25 of them minus 10 of them gives me 15 of them. And here I have 2 to the k's, so 35 of them minus 21 of them gives me 14 2 to the k's. Okay, so let's take an eye to see where were we going again? What? I think we were trying to get to here, yes? So I need exponents of k plus 1. I think we can do that. I think we can see this is 5 times 3 times 3 to the k. And this is 7 times 2, 2 to the k. So this gives me 5, 3 to the k plus 1, plus 14, 2 to the k plus 1. We got it.